this is similar to the previous one. We have the altitude of an equilateral triangle is 8 times the square root of 3. So we're going to pretend like this thing that I'm drawing here is an equilateral triangle. Oh, such a wonderful equilateral triangle. And an altitude, remember, goes from the vertex to a spot that is perpendicular to the base. So this would be our perpendicular altitude right here. And this height right here is 8 square roots of 3. Now remember, in an equilateral triangle, when we split it in half, we get a 30, 60, 90. So here's our 30-degree angle. Here's our 60-degree angle. Here's our 90-degree angle. So here's our short leg. And here's our long leg. So in order to find the area of this triangle, we need to take the base times the height and divide that by 2. So in order to find the base, we have to figure out what the short leg is. So remember that to go from the long leg to the short leg, we divide by the square root of 3. So we have 8 square roots of 3. And we're going to divide by the square root of 3. And so these two are going to cancel out. So the length of the short leg is 8, which means that the whole length of this side over here is 16. So I'm going to take this stuff out here. This whole thing right here is 16. So the area of a triangle is base times height divided by 2. So we know that the base and the height have to be perpendicular to each other. So here's the height, here's the base because they're perpendicular. So we have 8 square roots of 3 times the base, which is 16. And then all of this is divided by 2. So if we take 8 times 16, we get 128. We can't do anything with that square root of 3. It's just going to tag along at the end. But then we have to divide that by 2. And so we can't divide 3 by 2 because this is a radical. This one isn't. But I can divide 128 by 2, which is 64. So the area of this triangle is 64 square roots of 3.